Now we'll talk about MANETs, mobile ad hoc networks, and how they're used in Internet of Things to connect Internet of Things objects to bigger networks, to the Internet itself. And we'll talk a little bit about how the code that we're going to write, that you're going to write in class, and how you won't directly have to know the details of these things because you'll be writing generally high-level code, but still it's important for you to be familiar with these concepts. So a mobile ad hoc network, a MANET, it's a self-configuring network. By self-configuring, we mean that the hosts in the network configure themselves because they're moving around all the time. So their connectivity can change across time. So for instance, in this picture, you see a bunch of nodes. You see cell phones, some cell phones, a car, right? Whatever the IoT devices, there are a set of them. And then at the top middle, there's this access point. So this access point is the thing that connects our MANET to the main internet. Okay? Now, a MANET could be just independent and not connected to the internet at all, but most commonly, we're going to be connecting to the internet some way through an access point. Now, the access point is typically usually not mobile. It might be, it could be mobile, but commonly it's not mobile and often wired, right? So it'll have wireless connections to the IoT devices, but it might have a wired connection to the main internet. So the access point maybe isn't mobile, but everything else is. And the way I've drawn the diagram up there, I have lines between two nodes if they can communicate directly to each other. Meaning if they're in radio range and they have communication, right? So sometimes, like for instance, if you look at the cell phone all the way on the left versus the cell phone all the way on the right, they don't have an edge directly between them, okay? Because maybe they're out of range of each other, but they're both within range of the same access point. So they can communicate to each other through that access point, but not directly in this particular configuration. So the connections between these components changes all the time because these things are moving, right? So maybe these two cell phones, which couldn't talk to each other before, not directly anyway, the people who have the cell phones, they walk near each other, and suddenly there's a connection directly between them. But maybe the car can no longer connect to them because it just got out of range because it drove past, right? So these networks, their connections are coming and going over time. So that's what a mobile ad hoc network is. Now, important aspects of MANETs, one is a power budget. So you really have to worry about power when you're talking about MANETs because MANETs, each one of the devices is mobile. These IoT devices, they're all mobile. They're all running off of batteries, and the batteries can run out. So you have to generally change the protocol to be more power restrictive, right? It has to save power somehow. So that changes a lot of the way you do networking. So you send less data, for instance. You're restricted to sending less data because every piece of data you send, that's going to be some kind of power that you use to drive the antenna, right? So the battery is really important because batteries are heavy, right? I mean, batteries are often the heaviest component, are usually the heaviest component in these systems. I mean, I think about my quadcopter, the battery weighs as much as the rest of the whole copter. I mean, it's so big, right? And that thing lasts for 15 minutes of flight time. It's ridiculous. But you get the same thing with cell phones and all this, where the battery is, if not as heavy as everything else, at least it's the heaviest component in the system and the biggest single component in the system. So battery power is really important when you talk about MANET, so you change the protocol to save power. In addition, you typically have lower data rate. Because you're using less power, you probably have to send data more slowly, so you have less of a lower data rate. An example, sort of a ballpark example, is take Bluetooth. So you're familiar with Bluetooth, right? Bluetooth, and compare that to Bluetooth Low Energy. So Bluetooth is a networking protocol, wireless. Bluetooth Low Energy is also a networking protocol derived from Bluetooth, but it is a low energy version of Bluetooth. So Bluetooth, you can send video across Bluetooth. You can get enough data rate to transmit video reasonably well, okay? Now, Bluetooth Low Energy, there's no way you get the same data rate. It uses a lot less power, but you get a lot lower data rate, so you can't send video. So the fact that you're going to low power restricts you in terms of your data rate, and that restricts your functionality in a lot of different ways. Security. Often security costs you in terms of power, right? So security, say you want to do encryption, right? You want to take all your messages and encrypt them before sending or something like that. That takes power, right? It takes power to do those operations, to encrypt the data, decrypt the data. So security has a cost in terms of power, and since you're power constrained, maybe you can't do as much security as you wanted to do. Also things like antivirus tools, right? You never see antivirus tools for cell phones, or I think such a thing exists, but it's not common, right? But if you talk about an IoT device, like a watch or something, they don't have antivirus for that because the computational power just isn't there. It doesn't have the extra cycles to be able to do antivirus tasks at the same time as doing its regular tasks. Because because part of that, the reason for that is because these IoT devices, and we talked about this before, they're designed to be much more efficient. Meaning, a desktop laptop, 99.9% of the time it is being underutilized. Very rarely are you fully utilizing that processor. So it has extra cycles, extra power to be spent doing antivirus tasks or something like that. Embedded systems, which IoT devices are, they don't have those excess cycles, right? They use all the power they have, right? Or most of it. So they don't have extra cycles to just be doing antivirus without hurting the regular function of the system. So security often suffers in an IoT device because you don't have the power budget to do it, and you might not have the cost, you might not have the money to pay for the extra hardware that you would need. Now, in practice, when we do networking programming later in the specialization, there are levels in the stack, right? There are different layers in the stack: application, TCP, UDP, and all this. But we don't have to touch those directly in our coding. So when we use an Arduino or a Raspberry Pi, you will be calling library functions at the application layer. So your code is going to be at the application layer, almost exclusively at the application layer. So you call very simple functions which will take care of the details for you. So for instance, as an example, you might have a function called send message, an application layer function that sends a message to an IP address. Maybe you give it, typically you'd give an IP address and a port number, which we'll talk about later. You call send message, and it'll send that message to that IP address and that port number. And all the details of TCP, UDP, IP, and data link, that's all handled by the protocol stack. All you do is call the library function. Same thing on the receive. Maybe there's a receive message that does a similar thing. So you're making these calls at the application layer of these simple library functions, and the details are being handled by the library code itself, so you don't have to worry about that. Thank you.